Okay guys, this is organic video 3. You need your packet and your reference table. Reference table should go to table R. I want you to kind of see that that's there. You've seen it in class before. And we're going to deal with organic functional groups today. So using that table R and how we're going to name them. So I'd like for you now to go, I don't know if you see that, to packet page 7. So the first section of your packet. And this is a picture of table R. You can see I have extra examples on the end. So how you want to use this is we're going to focus on a few of the categories. So class of compound, that's always going to be important because that's going to tell you what it is. So is it a halide? Is it an alcohol? Is it an ether? So on and so forth. So that's extra functional groups that are in it. So that means I should check here. So if I call it something like a halide, then I can see that the functional group is it has either an F, a Cl, a Br, or an ion. Those are all in group 17, which is called your halogens. That is why they call them halides. I'm also going to look at the general formula. Now, this is what's important. In your general formulas, you're always going to see this R, this Rx, ROH, ROR, oh, with 2 R's. So if you want to look at the very bottom of this page, you can see that it says notes. R represents a bonded atom or group of atoms. I want you to think of your R's as being a bunch of C's and H's, basically. Okay? So your R equals C's and H's. C's and H's. So when they say R, they're just shortening it. And then, of course, we're going to use these examples. What you should be using these examples for, look at the endings. I need to know how to name all of my special organic groups, but I have to do that by knowing all of the endings. And that would be really hard to memorize. So you want to make sure that you're looking at the example, and then you can modify it for what you want. So let's just go ahead and start. So I start with my halides. Okay, so let's start right here. My halides, again, are my things in group 17. I see that my functional groups are F, Cl, Br, and I. So they tell me how they're actually going to name them here. Fluoro, chloro, bromo, iodo. So when I look at the general formula, it says Rx, and X represents any halogen. So it depends. I can have 4 different ones. So for instance, if I look at this example, it says 2-chloropropane. Well, I want to think about a few things. I know that prop means 3, so I'm getting 3 from there. Well, I have 1, 2, 3 C's, so there's my propane. And then my chloro is going to be my Cl, and look, I see a Cl right there. They're telling me 2-chloropropane because they're telling me the location. If I were going to draw this out, remember this is called your condensed formula. I could go CH3, then I'd have a C with an H on it. That must mean my Cl's kind of on the bottom. And then I'm going to have my other CH3. So that's what this would actually look like drawn out. I think that's a little more clear why I would call it 2-chloropropane. Here's my prop, 1, 2, 3. And my chloro is on my second carbon. So if I see this example, now I'm going to modify what I see here. So it says 2,3-dichlorobutane. So this is where I should be focusing. So let's just think first, okay, let's draw our butane. But means 4. So 1, 2, 3, 4. And then it says 2,3-dichloro. So I'm going to go over to my second carbon, and I'm going to put 1 Cl. I'm going to go over to my third carbon and put another Cl. I would fill the rest up with H's, and I'm done. So all I did was modify that first one was chloropropane, so a chlorine with 3 C's. This is dichlorobutane, so 4 C's, 2 Cl's. So just think for the halides, that's where you're going to get these names here, your fluoro, chloro, bromo, iodo. So now I'm on to alcohols. Alcohols, we've already learned a little bit about those. Alcohols are going to have your OH group. So I see that it says ROH, so that's what I'm looking for as my OH. And so if I look at this example, it says 1-propanol. Ooh, look at it, ends in ol. Propanol. So that means alcohols end in that ol ending. And I say prop because look, 1, 2, 3 C's. And here's my OH group. So 1-propanol means they're putting the OH group on one of the ends because it's 1, 3 C's. So if I were going to go over here to do ethanol, I would just think, okay, so I can either draw it out and go, eth means 2. All ending means I need to have an OH group, so I'll just put on the end. And then I'd fill in with my H's. So there's my ethanol. I could have also done it from my structural formula. Eth only means 2. So I would just go over here, and I would actually just get rid of one of those C's. So I'd go CH3, CH2, OH. Sorry, I squeezed that in. But see how all I did, if I look from here to here, all I did was take out the C's and H's to modify that. Now my alcohols are actually very, very special. So we're actually going to put a big star by those. Remember that I don't want to confuse them with bases because bases have OH, but then we're going all the way down to the bottom. So down here I want to talk about the types of alcohol. So I can have what's called a primary alcohol. A primary alcohol. Now primary alcohol means that I'm going to have, well let me show you. 2 C's, let's say I have an OH here, got H's here. This would be primary. So if I look here, my OH group, I want to look at the C that it's attached to. The OH group is bonded to a C. So OH bonded to C. But that C is bonded to one other C, which is bonded to one other C. So whenever my OH is bonded to a carbon that is touching only one other C, I call it a primary alcohol. That's going to be a little different than if I see a secondary alcohol. So a secondary alcohol would be something like this. Let's say I've got, I can just do 3 C's. Let's say I put an OH group here, bring 2-propanol. And if I look at the carbon that has that OH group on it. It's actually touching 2 other C's. So OH is bonded to C, which touches 2 other C's. So if it is touching the carbon that has the OH on it, if it's touching 2 other C's, it's called a secondary alcohol. And the last type of alcohol that I have would be a tertiary alcohol. So a tertiary alcohol. So these are going to be ones, they usually say they look like a T when you see them. So maybe something like this. And they could be even bigger. But if I look, this OH is attached to that C, but it's touching 1, 2, 3 other C's. So the OH carbon touches 3 C's. That's why it's called tertiary, because it touches 3 other C's. So not that the OH touches 3 Cs, just that the carbon that has gone touches 3 Cs. So they really like these, really like these. So you really want to know primary, secondary, and tertiary alcohols. If they ever give you more than one OH group, technically you could have, if you have 2 OH groups, they will call it a dihydroxy alcohol. So different from this primary, secondary, tertiary. But if there's 2, I call it a dihydroxy. If there's 3 OHs, which is a little more rare, but if there's 3 OHs, they would call it a trihydroxy. So just so you know the word, if you hear hydroxy, they're talking about alcohols, but it's kind of different if you have more than one. So again, you want to know primary, secondary, and tertiary, and you want to know that that means they end in that OL ending. So alcohols end in OL. So next would be my ethers. So my ethers have this O. So it goes R, O, R. So if you just have an O sitting in the middle of some C's, you have yourself an ether. And let's see, they call this methyl ethyl ether. It's kind of a funny name. Let's kind of see. Well, here's my O, so there's that ether. Where are they getting meth from? Well, meth means 1, and I see 1 C on this side. And then F means 2, and I see 2 carbons on this side. So they actually named each side of the chain, and then put that word ether after it. So methyl ethyl ether. So if I go over to this example, I'm going to look and I'm going to say, okay, I see my O, so this is an ether. I'm going to name this side. So the first side has 2 C's, so ethyl. Then the other side has 2 C's. So I could say ethyl ethyl ether, or I could say diethyl ether, because then I would be saying that I have both of them on there. But important that I have that ether. So the first example is methyl ethyl ether. Second example, I'm going to call it diethyl ether because I actually have an ethyl group on each side. Next, I come to my aldehydes. My aldehydes are going to have a C with an O and an H. So this is its group, a C with a double bond O and an H. Be careful, it's going to look a lot like an acid we'll get to in a second. So if I look, they call this propanal. Propanal. Notice that AL ending, AL, so L. It's not all like an OH group, it's an L for an aldehyde. So they call this propanal. Let's see, here's my group, so there's that aldehyde group. They're saying prop because it has 1, 2, 3 C's. So propanal. So if I go over here, here's my aldehyde. It has 1, 2, 3, 4 C's. So let's just change that prefix. Instead of prop, I say 4 by saying but. So but and L. Butanal. Notice all I did was modify it from the first one. I just had 1 more C, so I changed my prefix. Next would be our ketones. Our ketones have a C with a double bonded O. Notice it's different from my aldehyde, no H. So it'll just be a C with a double bonded O, and it'll have 2 R groups on either side. So if I look here, they're calling this 2-pentanone. So that means the -one ending is for your ketone. So here's that ketone group. And why are they saying pent? Well, I have 1, 2, 3, 4, 5 C's. Pent means 5. So 2 is telling me the location. And then pent is telling me 5 C's. And unknown is telling me it's a ketone group. So if I go over here, here's my ketone group. And I'm going to say, okay, well, where is it? It's on the second carbon, so I'm going to go 2. And then I'm going to count my C's. I have 3 C's this time. So instead of pent, I'm going to go propanone. Propanone. So notice I just stole that ending from over there. All I did was change my prefix because I had a different number of carbons. Notice when you're looking at this table, it really doesn't need to be harder than it is. Okay, next is our organic acids, which you knew acids had this "-ku" ending. Remember I told you they were special? Well, this is what the "-ku" ending actually looks like. It's a double bonded O with an OH group. So there's my actual functional group there. So I'll have a chain of C's and H's with a C with a double bonded O and an OH. So they're calling this propanoic acid. Propanoic acid. So that means I'm going to end my special organic acids in oic acid. So here's my actual group. Why are they saying prop? 1, 2, 3 C's. So there's my prop. And then they're telling me it has that acid group. So propanoic acid. So if I went over here to do ethanoic acid, I just want to think that F means 2. So instead of 3 C's, I'm actually going to have 2. So I'm going to just copy this. I have my CH3. I'm just going to take out that CH2. I'd have a C, double bonded O, OH. Make sure F means 2. I have 1, 2. I have my group ethanoic acid. All I did was modify the first one. Notice if you get rid of a C, you got to get rid of the H's that go on it as well. That's just the important part. Okay, we're almost there. Now I've got my esters. So esters are going to have this C with a double bonded O and an O. So look how close some of these are. So this is your actual group. So it's a C with a double bonded O with an O. I've got 2 groups on either side. So I look at this example and it says methylpropanoate. Methylpropanoate. So that O8 is going to be your esters. But notice there's 2 words. So let's identify where our ester group is. Here it is right here. And they're saying methylpropanoate. So meth means 1. So if I look over here, I've got 1 C that's hanging out at the end. There's my methyl. Well, where did my prop come from? Prop means 3. 1, 2, 3. So that means wherever my ester group is, the C that has the 2 O's touching it, that gets named with the first chain. And then the C that comes after it gets its other name, but it gets written first. So for example, let's go over here. Here's my group. I'm going to name this side first. So 1 C, 2 C's. I say 2 with F, so ethyl. And then I'm going to go back over here, and I'm going to say, okay, 1, 2, 3 C's, so prop. And I'm going to steal the rest of the word. Enoate. Ethyl propanoate. So the only difference was I changed how many C's are on the end. All right, next I have my amines. My amines, it's just an N. So if it's got an N, it can have 3 R groups on it. A lot of times it doesn't. A lot of times it's going to have just H's. But remember, R can be C's or H's, so it can be either. So this example says 1 propanamine. Propanamine. So if it's an amine, I'm going to just end it in amine. Let's see what they're saying. Prop, 1, 2, 3. There's my prop. Here's my amine right here. It's an N. It happens to have 2 H's on it. That's okay. Just focus on that there's an N. So 1 propanamine. So if I was going to go 2 propanamine, let's just copy this because all I'm doing is moving my amine group. So prop means 3. 1, 2, 3. On the second carbon, put your amine group, your N, fill in with C's, and I would just copy. That N had 2 H's on it, so I would just go with that and write NH2. So 2 propanamine because it's on the second one. Okay, last one. Last one is your amides. So amides are going to have a C with a double bonded O and an N, and at least 1 H. So these are the craziest kind of looking ones. Here it is. So they call this propanamide. So very close to the amines when I say amide. So let's see why we said prop. 1, 2, 3 C's. Here's that amide group with the double bonded O, and I've got an N. And I can either have H's or another C coming off of it. So if I go over here, I'm going to say, okay, here's my amide group. I have 2 C's, so instead of propanamide, F-enamide. So when you're looking at this table, what's super important really is that you're not getting overwhelmed by it and that you're just learning that I just have to go here so I could figure out what I'm going to call something, and then I manipulate it. So if you actually go to your packet page 20, I just want to give you a couple examples of that. So this is your packet page 20. And let's see. So I'm going to have you kind of name these. But what I would do is just, okay, if I start with the first one, I'm going to find my group that isn't just C's and H's, it's an F. If I go back here, I can see that an F was in my halide group. So they did this 2-chloropropane, so they're putting the name and the location, and they're writing just what the charge is. So I go over here, and I say, okay, well, the F is on the second carbon, so 2-fluoro. And then 1, 2, 3 C, so 2-fluoropropane. 2-fluoropropane. If I just did number 10, I'll do it because it's up here. I see that I have the C with a double bonded O. If I go to my table R, I'm going to see that that's a ketone. Ketones end in -one. So I'm just going to say, okay, well, how many C's do I have? 1, 2, 3, 4, 5. So pent, and I steal the rest of the word from table R, pentanone. And I got to see the location. So this is on the third carbon, so 3-pentanone. If I did number 11, I see my group right here. That's my acid group. I have a double bonded O and an OH. I have 1 C, so I'm going to go meth. And then if I look at my acid, it ends in oic acid. So meth and oic acid. So what I want you to do, I want you to go through these. I want you to do exactly what I was doing. I want you to box in the group. Box in the functional group. Finish this page. I'm checking it tomorrow. Thanks, guys. Have a good day.